Hello students, in this video we will continue our discussion of regression analysis. We are working on this question about the correlation relationship between hours of time studying and grade in a stats course. Remember, here's the values of the 7 students. More importantly, here are some key values we need in our formulas. We have calculated the Pearson correlation, we've calculated the intercept, we've calculated the slope, we put that together in the estimated regression line, we have estimated the grade based on hours of studying, and we have, based on the grade we want, we have determined how many hours we need to study in the previous video. In this video we will look at calculating R-squared and then a really quick overview of hypotheses testing and what's expected in this section. As I said before, this is something that's continued on in the second level of stats, so we're not going to spend a lot of time going through the hypotheses testing process here. But let's first calculate R-squared and find out what that means. So R-squared, really simple. R-squared is the R-squared value is called the coefficient of determination. It is simply just the R value, the Pearson correlation value squared. So in our example, we have R value, Pearson value to be 0.857. If we square that, we get R squared, which will work out to be approximately 0.734. R squared value, the correlation or the coefficient of determination, generally expressed as a percentage, so this would be the same as saying 73.4%. Now what the coefficient of determination measures is how well the independent variable x explains the variation in the dependent variable y. So once again, for x, the independent variable, we are using study time, and for y, we're trying to measure the grade. So as I've said before, there are probably other factors that we could use, other independent variables that we could use to determine the grade. Not just study time, but we could use attendance, we can use a grade in a previous course, we could use a grade in a high school course. All those could be used to determine or predict the grade in the stats course. Now, using study time has basically accounted for or has measured 73.4% of the variation in the dependent variable. So study time by itself is a pretty good measure and predictor of grades. So for R-squared value, the coefficient of determination, all we have to do once we calculate the Pearson coefficient correlation value is just square that value. Now we'll take a look at the little part of hypothesis testing we want to do. So that it states that the p-value is 0.0138, and there's a testing process we could do to actually find that p-value, but for the purpose of this course, we are going to provide you the p-value. Your task is to properly compare the p-value to the assumed or given level of alpha and determine if there's a significant relationship between the hours spent studying and the grade in the course. So let's clear this off. Basically, I will write what the null hypotheses would be. This is something that we don't have to do in this course. So the null hypotheses, I'm just going to say here that basically there is no relationship, no significant relationship, whereas the alternate hypotheses is basically states that there is evidence for a significant relationship between the two variables in question, between x and y. So that is our null and alternative hypotheses. If our decision rule is comparing p-value and alpha. So p-value is less than alpha. Basically, we are saying we are saying that there would be a significant relationship. Let's just abbreviate that, significant relationship. On the flip side, if the p-value is greater than alpha, there is no significant relationship. So if we look at our p-value, we know that p-value is given to us as 0.0138. Well, let me just confirm that. P-value 0.0138, and alpha is also given to us. Alpha is a standard 5%. So because the p-value is less than alpha, right there, looking at these values here, p-value is 1.38%, alpha is 5%, where we have evidence to state that there is a significant relationship. This one holds out that there is a significant relationship between study time and grades in a course. Now, if we were testing this at, let's just do this up here, if alpha was now 1% instead of 5%, the p-value is greater than alpha. So basically let's just put this, at alpha equals 1%, there would be no significant relationship. So remember that the level of alpha is based on your level of risk and your type 1 error. So that's something that is determined by the researcher, determined by the type of research we're doing, but generally 5% is an acceptable level of risk for hypothesis testing. So once again, 5% level of risk in terms of what alpha is, we would state that there is a significant relationship. If alpha were reduced to 1%, a very small level of risk, which means it's opening up our probability of making a type 2 error, there would be no significant relationship. So that is the extent of what we expect you to do in regression analysis. If you look back at our document, basically calculating this Pearson product, calculating the slope and intercept, determining the estimated regression line, putting the slope and intercept together, and then answering a couple general questions in parts E and F, calculating R-squared, and then making a statement in relation to the p-value and the level of alpha.